Hello friends, welcome back to my channel. Today I'll be talking about critical path method. Critical path method or CPM. It is a technique used for scheduling project activities. In my earlier videos on networking techniques, I have talked about arrow diagrams, activity on arrow diagram and activity on node diagrams, network diagrams. And then I have talked about terminology used in networking techniques. I have also discussed rules that are to be followed while constructing a networking diagram, specifically activity on arrow diagram. I hope you have watched those videos. For those who have not yet seen those videos, I am giving link to those videos in the description section. Please do watch those videos and subscribe to my channel. Today, continuing with networking techniques, as I said, I'll be talking about critical path method, or it is simply called CPM. Critical path method. This is a networking technique that is used in scheduling of project activities. So let us understand the method. CPM is an activity-based method. So when you have a project, the entire project work is divided into small activities, small tasks, and this is done by using work breakdown structure. So I'll be discussing work breakdown structure in my coming videos. You please uh, wait for those videos. So I was talking about the method. Critical path method. It is based on activity. It is based on project activities. So activity data, activity information is used in this method for scheduling project activities. So critical path method is an activity based method. It is concerned with what does it include, or what is included in this method. One is there is structure analysis. There is analysis of the network structure. So network diagram, when network diagram is ready, we have to first draw the network diagram. For drawing the network diagram, we need list of project activities. List of project activities will be available to us through the technique of work breakdown structure. So based on project activities that are to be performed, a network diagram is drawn and then that network diagram is analyzed. So there are two basic things that are involved in critical path method. First is there is analysis of the network diagram, that is structure analysis. Under this, what is done? First is you'll be preparing list of project activities, and preparation of list of project activities will be done by work breakdown structure, where the entire project work is divided into small tasks, small manageable tasks. These tasks are interrelated with each other, and all of them, when completed, they will result in achieving the project objective. ठीक है. So structure analysis involve preparing list of project activities. Then once you have the list of project activity, the network diagram is to be drawn. So second thing that is involved in this is drawing the network diagram. So here you can either draw AOA, that is activity on arrow diagram, or you can draw AON, that is activity on node diagram. In our discussion, we will be talking about activity on arrow diagram, or we will be dealing with activity on arrow diagram. Okay. Then the third task is numbering the events. Once you have drawn activity on arrow diagram, once you have drawn the network diagram, so there will be events that will be used for relating various activities. So after you have those events, you have to number those events. So for numbering the events, there are certain rules to be followed. I have already discussed about those rules in my earlier video. So numbering the events. So that completes structure analysis. After structure analysis is done, the next next analysis that is involved is time analysis. So what is done in this? An assessment of duration of activities. For all the activities, you'll be having certain durations. So an assessment of all those durations has to be done in this. Then forward and backward calculations are to be performed. We are going to understand these calculations in this video. Forward and backward past calculations are to be done. And finally, you have to assess the critical path. You have to uh, get the critical path for performing this project activities. Okay. So let us move ahead. Once having understood what is involved in critical path method, now let us go deep into the method. Okay. So before we understand the method, there are certain terms associated with this methods that needs to be understood. So first is earliest event time, and in our discussion, in my discussion, I have used it, I have represented it by this symbol EE, earliest event time. What is earliest event time? The earliest time by which an event can occur. For a event, the earliest time by which it can start, by the earliest time by which it can occur, that time is nothing but its earliest time. We call that as earliest event time. So like earliest event time, you also have latest event time, which we will be abbreviating as LE. And if you refer our definition for earliest event time, you can easily write information about latest event time. So what is this? The latest time by which an by which an event can occur. So that is latest event time. Then you have earliest start time of an activity, which we will be abbreviating as ESA. I have abbreviated as ESA, earliest start time of an activity. So what is this? This is the earliest time by which an activity can start. The earliest time by which an activity can start is its earliest start time. Similarly, you have latest start time of an activity, which will be denoted as LSA. What is that? The latest time by which an activity can start. The latest time by which an activity can start is its latest start time. Then you have earliest end time of an activity. So what is that? The earliest time by which an activity can end. The earliest time by which an activity can end is its earliest end time, and that will be denoted by EEA, earliest end time of an activity. And then finally you have latest end time of an activity, which will be denoted by LEA. And what is that? This is the latest time by which an activity can end. The latest time by which an activity can end is its latest end time, LEA. Okay. So on this slide, we have understood these terms. One is EE, that is earliest event time, LE, that is latest event time, ESA, that is earliest start time of an activity, LSA, that is latest start time of an activity, EEA, that is earliest end time of an activity, LEA, that is latest end time of an activity. Now let us understand what is the rule for all these times in the method in CPM, that is critical path method. So you have to understand it in a better way. I'm discussing a simple example. Why I'm calling it as a simple example? Because I have considered only two activities. So based on those activities, we will learn how to draw the network diagram. I have already discussed how to draw a network diagram when you have list of activities in my previous video. You please watch that video. So let us consider this two activities. So I have information about the activity. What is the activity? I have information about the duration of each of the activity, and I also have an information about which one is the predecessor activity. So first activity is activity A, and let us say that duration of this activity is dA. This is just a notation. Duration could be in days, number of weeks, number of months, so on and so forth. So for time being, let us denote that duration by dA, duration of activity A. And for activity A, there is no any predecessor activity. There is no any predecessor activity. Second activity in the list is activity B. Its duration is dB. Again, the same explanation applies over here also. This is just a notation. It is duration either in number of days, in number of weeks, or number of months. And finally, for activity B, there is a predecessor activity, and that is activity A. Okay, so you have list of project activities. Now next task, we have listed project activities. Now let us draw the network diagram. So for this simple example, the network diagram will be simple. So first, since activity A has no predecessor activity, it will be the starting activity. So it will be start at the starting events. One will be the starting event for activity A. Okay. So activity A will proceed for duration of dA, and then it will end at event 2. That is, event 2 is the end event for activity A. You can also understand this as event 1 is tail event for activity A, and event 2 is the head event for activity A. Okay. So once activity A is completed, as per information in the table, you can start activity B. So activity B will start, it will proceed for duration dB, and finally there will be end of that activity at event 3. So for activity B, 2 is the start event or the tail event, and 3 is the end event or the head event. Okay. So once for this uh, simple list of project activities, just two activities, you have this simple network diagram. So we have drawn the network diagram, and you can see this is activity on arrow diagram, where we have represented activities on an arrow. So you already know what is an activity on arrow diagram. Okay. Now first, forward pass calculations are to be performed. So let us understand what are these calculations. So to begin with, let us understand calculations for event 1. For event 1, there will be earliest event time, and that will be denoted as EE1, earliest event time for event 1. And in every case, you'll be starting it with 0. So earliest event time for event 1 is 0. Earliest event time for first event in the network diagram will always be 0. You have to start with this. So for event 1, earliest event time, that is EE1, is 0. So, and how that is represented? It will be represented below that event, below the circle that is representing event 1, and it will be shown in this rectangular box. That rectangular box will be divided into two parts. In the first part, we will be writing the earliest event time for event 1. So after you do calculations for event 1, next is you have to do calculation for activity A. Let us do calculation. What calculations are to be performed for activity A? Let us understand. First thing is, we have to know what is its earliest start time. Earliest start time for activity A. So that will be ESA for A, and this will be equal to the earliest event time for its tail event. So for activity A, tail event is 1, and we have the earliest event time for that event, and that will be equal to the earliest start time for that activity. In other words, for an activity, the earliest start time is equal to earliest event time for the tail event. You please understand this. Okay. So we have now we know what is earliest start time for activity A. Next is you have to calculate earliest end time for activity A. First, the start time and now the end time. Earliest end time for activity A is, the formula is earliest start time for that activity plus its duration. You please remember. So in this case, for activity A, the earliest end time, it will be earliest start time for that activity plus its duration. EEA, that is earliest end time for activity A, is equal to earliest start time for activity A plus duration of activity A. Okay. So after getting earliest end time, that ends our calculation for activity A. Now, once you complete calculations for activity A, let us do calculations for event 2. So for event 2, what is the case? You have to know what is its earliest event time. So earliest event time for event 2 will be equal to earliest end time of activity A. Okay. In other words, or in general, we can say that earliest event time for any event is equal to earliest end time of the activity of which the event is a head event. Are you understanding it? So in this case, you see event 2 is head event of activity A. Okay. So for the head event, the earliest event time will be equal to earliest end time of that activity. Earliest end time of that activity. For a head event, the earliest event time is equal to earliest end time of the activity, and in this case it is EE2 is equal to EEA. Event time, earliest event time for event 2 is equal to earliest end time of activity A. Activity A is ending at event 2, so for this end event the earliest event time will be end time of this activity. Okay. So I hope you have understood. If you have any doubt, you please do comment in the comment section of this video. So once you know EE2, you have to show it on the network diagram. So again, it will be shown in a rectangular box like this. So the box will be divided into two parts, and in the first part, we'll be writing EE2. Okay. So after we end our calculations for event 2, now let us move ahead. Now you have to do calculations for activity B. Now for activity B, what is the case? Once EE2 is known to you, that will be its earliest start time. So for activity B, earliest start time will be equal to earliest event time for the tail event. So for activity B, 2 is its tail event, and for that tail event, the earliest event time is EE2, and that will be equal to the earliest start time of the activity. So simply for activity B in this network diagram, you have ES, earliest start time of activity B, is equal to earliest event time of event 2. Okay. Then after you know the earliest start time, you have to calculate earliest end time. Earliest end time of activity B is equal to earliest start time of activity B plus duration of activity B. We have understood this. Just now we have understood this. So for activity B also, you have to calculate earliest end time. Earliest end time will be earliest start time plus duration of that activity. And finally, for the end event, event 3, earliest end time of activity B will be equal to the earliest event time of event 3. Okay. So once you calculate earliest end time for activity B, you are knowing earliest start time of or earliest event time of event 3, earliest event time for event 3. Okay, once you know EE3, represent it on the network diagram in this way. Okay, so this ends our forward pass calculations. So we have moved the uh, from the start of the network to the end of the network, and in moving so, for each of the event we have noted down their earliest event times. So in this simple diagram you just have 3 events, and that's why you have those a simple way of representing those events. So in general I can say in forward pass calculations you have to note down earliest event times for all the events in the network diagram. Okay. So after understanding forward pass calculations, now let us understand backward pass calculations. Now backward pass calculations will start at the end of the network diagram. So that means it will start at end event. So how are you going to start? Let start with the last event. So in this diagram the last event is event 3. So for event 3, EE3 is equal to LE3, that is earliest event time for event 3 is equal to latest event time for event 3. So this will be done in all the cases. For the end event this will be true. The earliest time will be equal to its latest time. Okay, so start with this. So once you have this, you'll be noting the latest event time in the next part of the rectangular box. So for now event 3, you have both the earliest event time and latest event time. Okay, so after event 3, let us move to activity B. Now we are moving from end event to the first event. So after event 3, let us move to activity B. And what is to be done? For activity B, latest end time of activity B will be equal to latest event time of event 3. So this will be the case. So latest end time is equal to latest event time. Latest end time of an activity is equal to latest event time of the head event. So once latest end time is known to you, you can calculate latest start time for that activity. So latest start time for activity B is equal to latest end time for activity B minus its duration. So now you must have noticed in backward calculation we are calculating latest start time, whereas in forward calculation we had done calculations for earliest start time. Okay. So latest start time of activity B is equal to latest end time of activity B minus its duration. Latest end time of activity B is nothing but latest event time of event 3. Event 3 happens to be the head event of activity B. Okay. So once you calculations for activity B are completed, now move on to event 2. Okay, so for event 2, what will be the case? Latest event time for event 2 will be equal to latest start time of activity B. Okay, so latest event time for event 2 is tail event of activity B. So for that event, the latest event time will be equal to latest start time of that activity. So LE2 is equal to LSAB, that is latest event time for event 2 is equal to LSA, that is latest start time for activity B. Okay, so once you know this for event 2, you note down that in the rectangular box, in the second part of rectangular box for event 2. Then after event 2, let us move to activity A. So same thing for activity A, latest end time of the activity, that is LEA, will be equal to latest event time for event 2. That means you are knowing what is the latest end time for activity A when latest event time for its head event is known. Okay. So once LEA, that is latest end time, is known, you can calculate latest start time. Latest start time for activity A is equal to latest end time for activity A minus its duration. Okay. And finally, for event 1, the latest start time for activity A is equal to its latest event time. That is, latest event time for event 1 is equal to latest start time for activity E. And finally, you can write uh, the latest event time for event 1 in the rectangular box. Okay. So in this way, backward pass calculations get completed. Okay. So in general, I can say in critical path method, in forward pass calculations, we are finding latest start time for every event. And in the backward pass calculations, we are finding latest event times for all the events in the network diagram. Okay, now let us move ahead. Now let us understand, the previous one was a simple example. Now let us understand if there are burst events or merge events in the network diagram, then how to do calculations for them. Burst event is an event from which two or more than two activities emerge. And merge event is that event where two or more activities end. So if you have this types of events in a network diagram, how to do calculations for this, let us understand. Let me tell you, network diagrams will be not as simple as the one that I have just discussed. They will be complicated. There will be burst events, there will be merge events, and for that you should know how calculations are to be performed for those events. So let us understand. So for that, again we will consider a little bit complicated example. So we have again list of activities. Again, same information is available with us. We know what is the activity, we know what is the duration of that activity, and then we know what is the predecessor activity. So predecessor activity is also known to us. Activity A, duration is DA. Again, I am using a general notation. No predecessor activity. Activity B, duration DB. No predecessor activity. Activity C, duration DC. Predecessor activity is A. Activity D, duration DD. Predecessor activity is B. And finally, last activity for this example is activity A, whose duration is DE, and there are two predecessor activities, activities C and D. Okay. Now first, as usual, first we will construct the network diagram. From the information that is given to us, information about the project activities, we will use that information to construct the network diagram. So let us understand this. So you look at the list. There are two activities, activity A and B, which do not have any predecessor activity. So how this information is incorporated into the network diagram. So what do you understand from this? We understand that both A and B, both activities will start at the same time. The meaning is both of the activities will have the same start event. Okay, so this is the event. I'm calling it as event 1. And so as you can number the event. Once there are two things, you first complete the network diagram and then go on numbering the event by following the rules, or you number the event as you go on drawing the network diagram. So I'm doing this thing. So first event is I'm calling it as event 1, and as per information, this will be the start event for activity A, which has duration of dA and which will be completing at event 2. Event 2 will be the end event. Okay. Activity B will also start at event 1. It will proceed for duration dB, and it will get the end event for this activity will be event 3. Okay. Then after activity A is completed, A and B are completed. Next is activity C, and for activity C, activity A is the uh, predecessor activity. That means after activity A, you can start activity C. Duration of the activity is DC, and at the same time, you can start activity D with duration dd. Why I'm doing this? Because for the next activity in the list, which is activity E, C and D both have to be completed. So we are completing it, and they will be completed. End event for this activities will be the same, that is event 4. Event 4 will be the end event for activity C and end event for activity D. Okay. Then from the last activity, from event 4, after C and D are completed, last activity will start. It will proceed for duration DE, and finally it will end at event 5. Okay. So in this network diagram, there are 5 events, and you can see the start event, that is event 1, is the burst event, because two activities, activity A and B, are emerging out of that event. Activity A and B, they are starting at event 1. That's why event 1 is the burst event. Whereas event 4, where activity C and D are ending, that events happen to be the merge event. Okay, so you have burst event and merge event in the same network diagram. And for this type of network diagrams, how to do forward pass calculations and then how to do backward pass calculations, that is what we are going to understand. Okay, so let us understand. Once the network diagram is ready with us, we will do the forward pass calculations. So forward pass calculations will start at event 1. The step is, earliest event time for event 1 will be 0. Once you have done for event 1, you have to do for activity A and B. First, let us do for activity A. So for activity A, earliest start time will be equal to earliest event time, EE1. And then once start time is fixed, you get the end time. Earliest end time of activity A is equal to earliest start time of activity A plus duration of activity A. Okay. Then for activity B, some similar calculations. Earliest start time for activity B will again be EE1, and then earliest end time for activity B will be earliest start time for activity B plus duration of B. Okay. Then after that, you have to do calculations for event 2. So for event 2, the thing is, earliest time for that event will be earliest end time of activity A. Similarly, for event 3, earliest event time will be earliest end time for activity B. So for event 2, for event 3, for event 2, you have EE2 is equal to EEA, that is earliest event time is equal to earliest activity time, earliest end time for activity A. Then for event 3, earliest event time is equal to earliest end time of activity B. That is EE3 is equal to EEA for B, earliest end time for activity B. Then you have to do calculations for activity C. So for activity C, again the earliest start time for activity C will be equal to earliest event time for event 2, that is earliest start time for activity C is equal to earliest event time for event 2, and then earliest end time for activity C will be earliest start time for activity C plus duration of activity C. Okay. So after activity C, next you have to do calculations for activity D. So for activity D, Again, earliest start time for activity D is equal to earliest event time for event 3. And then earliest end time for activity D will be earliest start time for activity D plus duration of activity D. Okay. So once you complete calculations for C and D, now the thing is for event 4, what will be the earliest event time? You have how to do the earliest event time for event 4. It could be equal to earliest end time for activity C or earliest end time for activity D. So you have two options which one to select, and that is what you have to learn in this. Out of EE, earliest end time for activity C and earliest end time for activity D, what is to be done? Whichever is maximum, that is set equal to earliest event time for event 4, and that is what you have to learn. That is what you have to remember over here. That was the objective of discussing this concept. Okay. So what is the case? Earliest for a merge event where two or more activities are ending at that event, what is to be done? The earliest event time for that event is equal to maximum of all the end time, activity end times, earliest end time of activities. Okay, so for here in this case, there are two activities. For each of the activity that is early, there is earliest end time. You have earliest end time of activity C. There will be some earliest end time for activity D. Whichever is maximum, you take it as earliest event time for event 4. That is that is what you have to remember. So for merge event, maximum is to be selected. Are you understanding it? Then that once that is understood, for activity A, calculations are simple. So what is the thing? The earliest start time for activity E will be equal to earliest event time for event 4. And then you calculate earliest end time of that activity. So earliest end time for activity E will be earliest start time for activity A plus its duration. And finally, you have for event 5, and for event 5, the earliest event time for event 5 will be equal to earliest end time for activity A, which has been calculated in the previous step. Okay, so once you come at the last event in the network diagram, your forward pass calculations get over. Now you have to do backward pass calculations. How to perform those backward pass calculations? Let us understand backward pass calculations. Okay, so for event 5, so as I said, in backward pass calculations, you start at the last event, and last event in this case is event number 5. So for event 5, what is done? The earliest event time is equal to latest event time. For last event, earliest event time is equal to the latest event time. So LE5, latest event time for event 5 is set equal to earliest event time for event 5. So that's why you have LE5, latest event time for event 5 is equal to earliest event time for event 5. Then move to activity E. So for activity E, latest end time for activity E is latest event time for event 5. So from this you find out latest start time for activity E, and that is latest end time for activity E minus duration of activity E. Then for event 4, you have latest event time for event 4 is equal to latest start time for activity E. Then after that, for activity D, again these two calculations. The latest end time for activity D will be latest event time for event 4, and latest start time for activity D will be equal to latest end time for activity D minus duration of activity D. Similarly, for activity C, or for event 3. For event 3, what is the case? Latest event time for event 3 will be equal to latest start time for activity D. Then for activity C, the latest end time for activity C will be equal to latest event time for event 3, and from that you have to get the latest end time. So latest end time for activity C will be equal to, yes, latest start time for activity C will be equal to latest end time for activity C minus duration. Then after that you come for activity B. So latest end time for activity B will be equal to, it will be set equal to latest event time for event 3. From that you get latest start time for activity B, which is latest end time for activity B minus duration of activity B. Then for activity A, again you calculate latest end time for activity A, which is equal to latest event time for event 2, and from that you get latest start time for activity A, which is latest end time for activity A minus its duration. And finally for event 1, again uh, for event 1, what should be the latest event time? That is the question, because you have two options. You can get latest event time for from activity A, or you can get it from activity B. Which one to select? So what is the case? There are two possibilities. One is latest event time for event 1 will be latest start time for activity A, or it is latest event time for event 1 is equal to latest start time for activity B. That means for event 1 the latest time will be either equal to latest start time for activity A or latest start time for activity B. Which one to select? What you have to do, you have to choose minimum out of this two. So out of this two, that is latest start time for activity A and latest start time for activity B, whichever is minimum, that will be selected as LE1, that is latest event time for event 1. So in this way backward pass calculations are to be done. So just now I have told you how to do calculations for a network diagram when you have burst or merge events involved in that diagram. Okay, so now let us understand whatever we have discussed in previous 2 or 3 slides. Let us understand on this single slide. So I have just taken the network diagram from the previous slide. So let us do. So you are starting at event 1 and you are setting earliest event time for that event as 0. So that will be represented over here. Then from that we will be doing calculations for event 3, and what calculations we will be finding out its earliest event time. So earliest event time for event 2 will be earliest event time for event 1 plus duration of that activity, and we will be representing it in the rectangular box. Then for event 3, earliest event time will be earliest event time for event 1 plus duration of activity B. So it will be EE3. We will be representing it. So earliest event time plus duration, that will give earliest event time. Earliest event time plus duration, that will give earliest event time. Earliest event time of the tail event plus duration of the activity is equal to earliest event time of the head activity. Here also, earliest event time for the tail event plus duration of the activity is equal to earliest event time of the head event. Then for event 4, you have two things. One is uh, earliest event time for event 4 will be EE2 plus DC, that is duration of C. Please note EE2 is nothing but earliest start time for activity C. You have understood this in our previous slide. Okay. So EE2 is nothing but earliest start time for activity C. This is one possibility. The other possibility is you can get it from this activity. So you can get EE4 as earliest event time for event 3 plus duration of activity D. There are two possibilities. You can get EE4 in this two ways, but what is the case? you have to, out of this two, you have to select the maximum one, and that will be entered as earliest event time for event 4. Okay. And finally for event 5, the earliest event time will be equal to earliest event time for tail event plus duration of the activity. So it will be EE5 is equal to EE4 plus DE. Okay. So that ends. So you started over here and we completed the forward pass calculations at the last event. Okay. So you have the earliest event time, and now set earliest event time for the last event is equal to its latest event time. So EE5 is equal to LE5. Then for event 4, the latest event time LE4 will be equal to latest event time for event 5 minus duration of this. So that will give you LE4. Similarly, over here for event 3, you'll get latest event time as latest event time for 4 minus duration of activity D. Similarly, for event 2, you'll get the latest event time. LE2 is equal to LE4 minus duration of this activity. So that will give you LE2. Okay. Now, when for moving from event 2 to event 1, and then for you can you can reach event 1 either from event 2 or event 3. So for each of the case, for if you are moving from event 3 to event 1, LE1 will be calculated like this. Latest event time for event 1 is equal to latest event time for event 3 minus duration of activity B. Or if you are moving in this direction, on this way, you get latest event time for event T is equal to latest event time for event 2 minus duration of activity A. So what you have to do, out of this two, select the minimum. So in backward pass calculations, when you are in a situation like this, select the minimum. And during forward pass calculations, when you are at the merge event, select the maximum one. So that will give you LE1. Okay. So in this way, I have discussed how you already know how to draw a network diagram. Specifically, you know how to draw activity on arrow diagram when list of project activities is available with you. Okay. So in this video, we have started. I have started discussion on critical path method. I'm going to end this video at this particular point of time where I have discussed how to do forward pass calculations and how to do backward pass calculations. And in those calculations, what are the terms like earliest event time, latest event time, earliest start time of an activity, earliest end time of an activity, latest start time of an activity, latest end time of an activity, and how to calculate all this. So with this, I end my uh, discussion for the present video. I hope you have understood the concepts. If you have any doubt, you please write those in the comment section. Please subscribe to my channel. Ask your friends to subscribe to the channel. Let me tell you, I'm going to post many videos on chemical engineering, on various aspects of chemical engineering. I'll be simultaneously I'll be posting my videos on mass transfer operations. So please do subscribe to my channel, hit the bell icon so that you will be notified once I upload a new video. And if you have liked the video, you please click the like button. Thank you for being with us. Hope to see you soon.